The velocity v in meters per second of a falling object on Earth after t seconds, ignoring the effect of air resistance, is modeled by the equation v is equal to 9.8t. And there is a different linear relationship between time and velocity on Mars as shown in the table below. So this is a table that we have here. Now, if an object dropped towards the surface of Earth has a velocity of 58.8 meters per second after t seconds, what would be the velocity of the same object dropped towards the surface of Earth after t seconds, ignoring the effect of air resistance? So as I read through this question, what we need to do is we need to find out at what time the velocity of an object that is dropping towards the surface of the Earth has a velocity of 58.8 meters per second, and for the same time we'll have to find the velocity of the same object that is dropping towards the surface of Mars. So let's start with finding the linear relationship between time and velocity on Mars. So we can take it as Vm, which will be the velocity on the surface of Mars, is equal to at plus c, where a and c are constants. So let's start with substituting these values. So we know at time t is equal to 4, the velocity is 14.8. So we can write 14.8 is equal to 4a plus c. This will be our equation number 1. And at time 8 the velocity is 29.6, so 29.6 should be equal to 8a plus c. This will be our equation number 2. Now we need to solve for a and c, so let's start with subtracting these two equations, which will help us to eliminate c. So we find out that minus 14.8 should be equal to minus 4a. This will be this, which gives us a as 3.7. Now let's substitute the value of a in the first equation to find out the value of c. So 14.8 should be 3.7 into 4 plus c. So 14.8 is equal to 14.8 plus c, which implies c should be 0. So after finding out, we know velocity of an object on surface of Mars will be this. Vm should be 3.7 into t. So now we have found the relationship between time and velocity on the surface of Mars as well. So let's start with finding out the time instance when the velocity of an object on the surface of Earth is 58.8. So we know 58.8 is equal to 9.8 into t. So let's see what is the time when the velocity is 58.8. 58.8 divided by 9.8. So if I solve using my calculator, I get t is equal to 6. So we know t is equal to 6 when the velocity is 58.8. So let's substitute this t is equal to 6 here. So we can find Vm is equal to 3.7 into 6. This will come to somewhere close to 22.2. So let's look at the options here. Option B is the right answer.